This problem is Valid Sudoku, where I'll be checking if a partially filled Sudoku is valid or not. And it's based on 3 rules of whether or not it's valid. Each row must contain the digits 1 through 9 without repetition. Each column must contain the digits 1 through 9 without repetition. And each of the 9 3x3 sub-boxes of the grid must contain digits 1 through 9 without repetition. So it'll be, one box will be like this: 5, 3, 6, 9, 8. That's one box, and another box is 7, 1, 9, 5, and so on and so forth. So those are the 9 sub boxes. So in the rows, horizontally across, columns vertically across. And how I'll be receiving input will be a list of 9 lists, and each of the 9 lists is a string of the inputs for a Sudoku board. They're all strings, and all the periods represents a blank in the Sudoku board. So here, after the 5, 3, here will be a blank. So my understanding is that input is a list of 9 lists. Each of the 9 lists contains strings to represent the entries in this Sudoku board, the numbers, entry numbers on the Sudoku board. And I know the output is a boolean. It's a boolean, true if the board is valid, false if otherwise not valid. So that's what I have the understanding of. And since I have a list of 9 lists, I won't be just needing a for loop, but I'll be needing the nested for loops to go through everything. A 2D array always involves a nested loops, so for loops for the rows, for the columns, and for the 3x3s. I haven't seen a problem very similar to this, but I believe something of just, if you're used to dealing with 2D arrays, which I should be from C++, I'm used to seeing this, like making a tic-tac-toe game, or what else, or predator and prey kind of thing. Well, in any case, the plan is I need multiple for loops, so let's deal with rows for now. So if I want to check just the rows, I'll need a for loop. I represent the row number, and there are 9 rows, so 9. And for the inner for loop, or let's call it J, in the range of, again, 9, because they're, so from left to right there are 9 spaces, so that's what I need to check. Oh, I forgot, I need a empty list. Have seen as I'll be using a kind of a hash method to figure out whether or not this is a valid Sudoku. So if let's see, if the board at I and J is in have seen, is in have seen, then, well, I've already filled, so I'm going to return false. I'm assuming this is a function and not just printing false. So I'll be return false. Else I'll add it onto the have seen. So I haven't seen it. Time to append the number at I and j. After the inner for loop is done, because I only need those 9 numbers, or potentially 9, I always need to clear the have seen list for the next row. So I need to make sure, otherwise I will find an immediate fail, a false failure, a false false. So that's for the rows. And for the columns, I can just take advantage of the fact that I'll still need to go through 0 through 9 and 0 through 9. So I'll be making this if statement for of j and I. And I'll be looking at this vertically now. So that also means I need a second list. So let's call this row have seen. And let's call this call have seen. I'll need these 2 empty lists. So this is now the column. And I just need to check if ji, the I and j is flipped, is in Jesus in column have seen. And same deal. Return false. Else call have seen append board ji, not ij, but ji this time. So this is what the plan is, and that's just to check the rows in columns. As for the 3x3s, I'll be using a different kind of for loop. In fact, I'll be making a helper function. So for now, I'm just going to call it check 3x3. I'm going to take in the board and the position. How am I going to do this position is I'll call this position of like where 5, 3, 6, 9, 8 is. I'll call that position 0. For the 7, 9, 5, I'll call that position 1. Here, position 2. This is position 3, where 8, 4, 7 is. The 6, 8, 3, 2. That'll be position 4, 5, 6, 7, 8. So 0 through 8, 9 spots. That's how I'll be considering these 3x3s. So this will be my helper function here. And how I would do this is let's see. I'm checking a 3x3, so I only need to check 3 across, and I need to check 3 down. So it's another double for loop, but only goes 3 on the outer, 3 in the inner. So let's call it, well, since it's a function, I can use the same name. So rows is equal to, let's see, position, and I'm going to divide this floor divide by 3. and I need this to happen first, so that at 0, 1, and 2 I always get 0 for the rows. So that's how I'll be doing it. I'll also multiply by 3 to indicate. So if it's 0, 1, 2, I'll always have 0. If it's 4, 5, 6, I'll always have 3, indicating that I'll be in the third row. So at 3, 4, 5. And I'll need the columns. In this case is position modulus 3. I need the remainder. Again, I'll need to multiply this by 3. So that at 0 modulus 3, it's just 0. So let's say I want the position of, let's say I want position of 5. So I know that means this number here is 3 by 3. Well, I mean 0, 1, 2, 3, and then from up to down is also 0, 1, 2, 3. So at position 5, so 5 floor divided by 3, 1. So I'll be starting at 3 here. 5 modulus 3, that's 2. 2 times 3, so that's snap 5. I want position 5, so I need this one. So down 3, 6 across. So then, yeah, that makes sense. So 5 modulus 3, 2 times 3 is at 6, which is here. So 0, 1, 2, 3, 4, 5, 6. And here, I need to start at 6. So whatever my position will always be correct. And how the for loop works is, can't forget the have seen. The for loop is just from rows to rows plus 3, and columns, so columns from columns plus 3. Oh, no S. Plus 3. These are my 2 for loops. And I just need to continue doing the same thing. If, let's just say L, I'll use L and I'll use M here. L and M. And if board L, M is in tab C, return false. Else, add on to the list. So C, append board L, M. Alright, I forgot to return true. So if everything gets through, this false never gets triggered, return true. And same for the original function, I need to return true. Return true. And I'll be calling this function here. So if check 3 by 3, if it's equal to false, or in Python terms, if not checked 3 by 3, then return false. And if it's false, I should never reach this return true, and that's the plan. And to modify this plan a little, I don't want to put also the periods. I'll be checking whether or not it's a number, and if it's inside the array I've already in the have scenes, and instead of else, it should be if it's a number, or ij, and I just need to check if it is numeric. If it's not a number, I don't want it in the have seen list. There's no point to put it there. And that's pretty much the plan. It's that should be fine. Here I have this is my check 3 by 3, just following the same things. I don't think I even need to clear this list. And again, the same things I have done, I showed in my plan. I was checking if it's a number, and I needed see if it's inside the have seen, return false, return false. And I need to check the 9 spots in each of the 3 by 3s. So if it's false, then return false, and if anything here reaches false, I'll never just return true. And that should be my plan, and I tested everything and everything's worked so far. So let's check board 5. It's false. So check board 2, which I know to be true, should be true. And there you go.